Hey guys, welcome back. I'm really happy to bring you this lesson today and have that opportunity to do that. Think you guys will enjoy it as we dive in further into Envision. So before we begin today, I just want to remind you of some changes. Today you have two assignments. You have your Edpuzzle video, which you're completing now, as well as your Envision assignment. Okay, I'm gonna recommend to you guys that you may want to use graph paper if you have that. If not, you may want to draw out the coordinate plane for parts of today's lesson. Okay. And then on Thursday, just as a reminder, you will have Math Olympics event number 6, okay, as well as another Edpuzzle video lesson, but a review of kind of today's topic and some other content that we've covered. Okay, so look forward to that coming as well. But we're going to move on today. So, per keeping up with our 6th grade trivia, today I thought I would theme it more around some holidays. We just had Easter last week, so I thought we would keep it going with a little holiday 6th grade trivia. The holiday we're going to focus on is Halloween. So 6th grade for me was actually the last year that I dressed up and went trick-or-treating. It's kind of a little bit forced to do it by some friends, but I was glad I did it. But that was the last year that I dressed up, went out trick-or-treating. I was never really big into candy, still not. So I didn't do it for all the candy, but I really enjoyed the festivities and the social aspects of it. Anyway, my question for you guys today is, what do you think I dressed up as, or what my costume was for my last trick-or-treating, at least for now, until I guess I'll probably dress up when I have children and I take them trick-or-treating. But my last time as a child in 6th grade, what do you think my costume was? The only hint that I can conceivably think of that might help you would be it could be somewhat fitting for the future profession of being a math teacher that I chose. I don't know if that's really helpful in getting you to what the costume was, but maybe some people would associate math teachers to be this type of costume. And then I want to hear from you guys as what your most recent costume was. I do remember what some of your costumes were. And then you can tell me what your favorite Halloween costume was, as well as maybe what future Halloween costume that you want to be as well. Okay? So go ahead and take a moment and do that now. All right, guys. We are going to jump into our lesson today, which deals with 11.4 and the composition of transformations. So what that means is we're going to look at figures on the coordinate plane, and we're going to do multiple transformations. So what the composition or composing transformations is just multiple transformations taking place at once. Okay. Just a quick review. I want to know from you guys, what are the 3 types of transformations that we have learned thus far? Go ahead and take a moment and do that now. All right, guys. So the transformations that we've covered so far are translations, which was just sliding across an object on the coordinate plane. Reflections, creating that mirror image of an object or a figure. And then rotations, turning that object and or figure on the coordinate plane. Moving on, we're going to look at multiple transformations. So, as I said before, it's going to be a combination of those 3 transformations. It could only be 2, it could be 3, it could be using multiple ones of the same one. Okay, you could reflect and then reflect again. So here we have Ava. who's using interior design software to design the layout of her family room. She wants to move the corner of the fireplace to the top right corner of the room, highlighted here. So here's the fireplace, and Ava wants to move it over this way. So we need to think about what transformations we can use to accomplish this. There's actually quite a few that you could do. Let's focus on a multi-transformation first. So one transformation that you can make at the beginning is a translation, where you shift and move the fireplace over 15 units. Okay? I don't know how you're going to move a fireplace that is burning or on. I don't know. But either way, they've moved it across the room to the other side. And that was 15 units. However, if you just take the fireplace and push it straight across, it's just going to look like this on the other side. Kind of awkward. None of these people over here are going to see the fireplace. It's not really serving an atmosphere purpose there. So there's another transformation that you're going to have to make. Okay? And that other transformation you're going to have to make is the rotation. So notice that it was here, and you just have to rotate it 90 degrees, and it would fit in that corner. Okay? So that would be, a multiple transformation that we have here. We translate it first, and then we rotate it. Okay? I want you to look at this same image again. I want you to think, is there a single transformation that could move this fireplace to the corner? I want to know what kind of transformation that would be. Now, when I say single transformation, I mean one singular move to get it exactly there. Go ahead, take a moment and see if you guys can answer that. Okay, guys, to figure out the single transformation, it's actually a reflection. Okay, you would create a line of reflection of the middle of the room, and when you do that, you would get an exact copy or mirror image of that on the other side. Let's keep on going. So we're going to translate quadrilateral MNPQ 7 units to the left, and then reflect it across the line x equals -3. Now, recall that x equals -3 is, looking at the x-axis, -3, and we're looking at this grid line that goes all the way up and down. All right. Think that if you were thinking like longitude and latitude, that'd be like the longitude line from social studies that's going up and down. Okay. But first we have to go 7 units to the left. It'll usually give you the order that it wants the transformations done. So 7 units to the left, we're going to do that, and then we're going to reflect it. Okay. This type of transformation does have a special name. It's called a glide reflection. Okay. The reason it's called a glide reflection is because you are translating and then reflecting. Okay. Think of like you're gliding the image over, and then you're just reflecting what that image is going to be. So breaking it down, it's going to look something like this. So we have n, the whole point, n is moved over 7 units, and that gives us n prime. We would do the same thing for the rest of them, for m to m prime, p to p prime, and q to q prime. Notice when you're translating this that only the x-axis coordinate is changed. The y-axis coordinate actually stays the same going across. Well, now after we've translated, we have to reflect it over our x equals -3. So we're going to have to reflect this image over that line now. Okay, we're not going back to the original one. We're finished with that. So here's our line of reflection over x equals -3. To create the reflection just like you guys have done before, it's a little different because most of them that you've dealt with, you haven't had the line of reflection inside the image or inside the figure. But in this time, it actually cuts through our image. Well, you're going to do the same thing that you've done before. You're going to figure out the distance from each one of these points on the figure to the line of reflection. Okay? In prime is 1 unit away. So its reflection will also be 1 unit away right here. Okay? And that, we're not going to call it n prime because n prime is at this location on the coordinate plane. So now we go a little further, and this would be called n double prime. Okay? Then we do the same thing with m, or m prime. So we have m prime is 2 units away, and that would actually take the spot over here. So we have m double prime over here. P prime 2 units away, it would be moved here, and there's p double prime. Q is here, or Q prime is 1 unit away. Q double prime will also be 1 unit away. And then you could connect, and you would get an image that looks like this. Okay. So notice here we had one transformation, which was a translation over, and then a reflection, another transformation, which was a reflection. Because that was 2 transformations, we had to go to double prime. If there was 3 transformations, it would be triple prime, 4 quadruple prime, and so on and so forth. Okay, so let's keep on going on. All right, what is a sequence of transformations that maps triangle ABC onto triangle A double prime, B double prime, C double prime, located here? I want you guys to take a moment and answer this question. How many transformations occur to go from triangle ABC to triangle A double prime, B double prime, C double prime? Go ahead and do that now. Okay, so there are 2 transformations that are happening. How you know this is because it went from the triangle ABC, and all the other points in the second triangle are all double primes. So that tells you that there were 2 transformations occurring. Let's take a look at what these 2 possible transformations could be, because there's actually multiple. So one way you could transform this image is you could perform a translation of 8 units to the right and 6 units down. When you do that, you have A prime, B prime, and C prime all located in this new position. Well, if you look at triangle A prime, B prime, C prime, and its image, A double prime, B double prime, C double prime, okay, what's the other possible transformation that could occur here? Well, the only possible other transformation where you would get this image on the other side would be reflection. Okay, because notice how it's like if you were to take this image and flip it over on its other side, you're going to get that mirror image. Okay, so the line of reflection is actually going to be the y-axis. How we know this is because each one of the points in its image point are the same distance from the y-axis. Okay? So we translated first, got to all of our primes, then reflected to get to our double primes. Okay, so how we would describe this transformation is a translation of 8 units to the right and 6 units down, and then a reflection over the y-axis. Okay. So another sequence that you could do is actually reflect across x equals -4 and then translate it 6 units down. So it would look something like this. So here's the reflection over x equals -4 and then translate it down. Alright guys, I want you to take a moment and analyze this one and tell me what you believe. So describe what the sequence of rigid motions that's going to map triangle QRS to triangle TUV. Now notice they don't do double primes here or any type of primes, so they actually use different letters. I want you guys to take a moment and see if you can figure out what the transformation is that happens to go from this triangle SQR to TUV. Go ahead and do that now. So to figure this one out, it's a translation of 3 units to the left, so I used point Q, 3 units to the left, and 5 units down. Then, once you get to this point, you're going to reflect it over the y-axis. So once you get down to this point, which kind of looks like this, and then you reflect over the y-axis.